Welcome back, mathematicians. In this video, we are going to solve a quadratic equation by completing the squares. We're going to start with this equation by subtracting 35 to both sides. Our goal here is to move the constant over to the other side of the equal sign so that all we have left on the one side is the quadratic term x squared and the constant term, linear term 12x. Now I'm going to leave a little bit of space here after the 12x strategically. I would recommend doing the same, and this is equal to negative 35. Now, what we want to do here is add in a constant to the left side, which makes this a perfect square trinomial. More on that in a minute. The constant term that we will add to both sides comes from a formula, and that would be b divided by 2 quantity squared. Well, in this case, b happens to be 12, so that's 12 divided by 2 quantity squared. 12 divided by 2 is 6, so that's 6 squared. So then what we're going to add into both sides is 36. So we're adding 36. Now that's always going to result in a positive value, which is why we know we will be adding that value to both sides, always never subtracting. Now the other thing, or the next thing we're going to do, is factor the left side. So when we factor the left side, we notice something really interesting happening. What we have here is a factor of x plus 6 times another factor, which happens to be an identical factor of another x plus 6. And that's kind of the point. When you have a perfect square trinomial, that will factor into two binomials, which happen to be exactly the same. On the right side, negative 35 plus 36 is equal to 1. On the left side, we can rewrite this, because those factors are identical, into x plus 6 quantity squared still equal to 1. Now we can take the square root of both sides. And when we take the square root of the left side, it undoes the squared, so we're left with x plus 6. When we take the square root of 1, we get a value of 1, but we must include a plus or minus. So anytime we take the square root of both sides to solve an equation, we are going to include a plus or minus on the side that is opposite the exponent, the squared that we were trying to undo. This now gives us two equations. Our first equation is x plus 6 is equal to positive 1. We will subtract 6 to both sides, and so we get a solution of x is equal to negative 5. And then our second equation is actually going to be x plus 6 is equal to negative 1. We are also going to subtract 6 to both sides, giving us a solution of x is equal to negative 7. So our two solutions are negative 5 and negative 7. Now you might be thinking, hey, couldn't we have factored this from the very beginning? And the answer is yes. I just wanted to do an equation that would result in two integer solutions, which means it could have been factored, but I wanted to go through the completing the squares process. All right, guys, good luck.